Alex O'Connor recently released a video called Confusing ChatGPT with an Impossible Paradox. In the video, Alex is asking ChatGPT to teach him how to clap his hands, but he runs into a philosophical problem.
In order to clap my hands, I will first have to pass that halfway point between them. And once I've reached that point, to clap my hands from there, I will, in fact, by physical necessity, have to reach the halfway point again between those two positions of my hand. And once I've halved that distance, I'll have to half it again and again. And it's physically impossible for me to close that distance without passing through the halfway point. But a moment ago, you told me that there are an infinite number of halfway points for me to cover. And so surely clapping my hands is impossible. That's what's making me a bit nervous about all this.
Now, the video is meant to be a bit silly, but ChatGPT suggests there's a mathematical limitation here, and that's actually a misinterpretation of what math tells us about motion in space. This mistake goes uncorrected by Alex.
Reality matches the math here.
Oh, I see. So in this case, conveniently, I can just assume that reality will match up with the mathematics. But when it comes to halving the distance between them, suddenly maybe it's mathematically infinite, but in practice the math just doesn't apply.
I see your point. Math is a tool to describe reality. Mathematically, yes, there are infinite points, but physically, your hands can still meet. It's the difference between theoretical infinity and practical action.
As someone who loves math and cares probably too much that people believe in true things, I found this video a bit concerning. The comments are full of misconceptions and supposed solutions to the problem. Many bring up physics, like the distance at which atoms start to repel or the Planck length, but those answers misunderstand what's actually going on. For one, the Planck length doesn't mean that space isn't infinitely divisible. In fact, modern physics still assumes it is. More importantly, the issue isn't about where the endpoint is, it's that there's an endpoint at all. Even if we define that endpoint as the position needed for atoms to repel and produce a clapping sound, we still have to pass through infinitely many halfway points to get there. The answer doesn't lie in physics, it lies in math. This is a variation of Zeno's Dichotomy paradox, which can be formulated as follows. Atalanta, a Greek heroine, must walk to the end of a path. Let's say the path is 1 kilometer long. To reach the end, she must first pass halfway. After she passes the first half, she must pass the next halfway point, 1/4 the total distance. After that, she must pass half of what's left, 1/8 of the total distance. These are true statements. She really must pass each of these points to get to the end of the path. The problem is that it seems we can keep dividing the distance infinitely many times. She must also pass the point where just 1/16 of the distance is left, then 1/32, and so on. Intuitively, this feels like a problem. It appears she must pass through infinitely many points just to travel a finite distance. How can that be possible? This is the so-called impossible paradox that Alex is describing in his video. It turns out, however, that there is no paradox. The issue is with our intuition. It seems paradoxical to need to pass infinitely many points to travel a finite distance, but that's only because infinity is something our brains struggle with. In fact, this kind of struggle is part of what led us to invent a new kind of mathematics, calculus. If you want to look more into it, you can explore the idea of the convergence of infinite series. But you don't actually need calculus to see the solution. We can also show how this works by using a little algebra trick. At first, Atalanta must travel half the distance, or half a kilometer. Next, she must travel half of that distance, or 1/4 a kilometer. We'll add that to the first distance she's traveled, so after 2 steps, she's traveled a total of 3/4 a kilometer. Next, she'll travel 1/8 a kilometer, then 1/16, then 1/32. Because there are infinitely many halfway points, I need to keep adding numbers forever. Intuitively, even though we know the numbers get smaller and smaller, it may seem that if we add small positive numbers forever, we're going to get an infinitely large distance as our answer. Since there's some confusion about how far Atalanta will actually travel, let's represent the total distance by the letter S. I'm going to do something that may seem strange and multiply both sides of the equation by 2. This is actually a common trick for sums like this. Since we're dividing by 2 at each step, multiplying by 2 is going to give us a nice result. Just to reassure any viewers, it's okay to do this. We can look at a much more basic equation, like 1 plus 1 equals 2. If I multiply both sides by 2, I get 2 plus 2 equals 4, which is still a true equation. That's the same thing that's happening here. It's just that there are fractions and the addition goes on forever. At first, this may not look like we've done anything helpful. The first number in my sum is 1 now, but the rest of the sum looks exactly the same. Next we have 1/2, then 1/4, then 1/8, and so on forever. But now I'm going to subtract s, my original sum, from 2s, this new sum. On the left side, I have 2s minus the original s, which brings me back to 1s, or just s. Okay, why would I do that? Because look at the other side. I can match up every single term in s to the terms after 1 in 2s. 1/2 minus 1/2 is 0. 1/4 minus 1/4 is 0. 1/8 minus 1/8 is 0. I can keep subtracting forever, and every term in s is also going to be in 2s. They will all cancel out to 0. Everything but the 1. Now I have an equation that says s equals 1, which means the answer to the infinite sum 1/2 plus 1/4 plus 1/8 plus 1/16 and so on is exactly 1. And that makes sense. Atalanta needed to travel a distance of 1 kilometer. So it turns out Atalanta can pass infinitely many halfway points and only travel a finite distance. We can do the same trick with the clapping example. Alex's hands begin 1/2 meter apart. To bring them together to clap, he needs to first pass 1/4 the distance, then 1/8 the distance, then 1/16 the distance, and so on. Let's call this one C, for how far Alex needs to move his hands in order to clap. Once again, I'll multiply both sides by 2 and subtract C from 2C. 1/4 minus 1/4 is 0, 1/8 minus 1/8 is 0, 1/16 minus 1/16 is 0, and so on. The only term I have left is 1/2, which is exactly the right answer. He needed to move his hands 1/2 meter to clap. He can pass infinitely many halfway points to clap his hands and doesn't need to worry about blowing up the universe. He'll just move his hands 1/2 meter. It turns out there's no paradox at all. The problem here is not math. It's our intuition. We really struggle to think clearly about concepts involving infinity. But this is exactly where math shines. Far from an impossible paradox, it's a beautiful demonstration of how math can help us think through things previously thought to be impossible.